Assalamualaikum. We are from Group 5. The title for our project is Noise Level of Vehicle Travelling along Jalan Kampus UTHM bersebelahan McDonald. Assalamualaikum. My name is Effa, Ayuni, Binti, Anuar. My metric number is AF230056. So now I will talk about the introduction for this project. This study investigates traffic noise pollution near McDonald along Jalan Kampus UTHM, a busy two-lane road linking student housing and a business area to the campus. High vehicle flow, especially motorcycle, car, van and lorries during peak hour lead to elevated noise level, impacting the well-being of UTHM community. Noise level will be measured throughout the day and categorized by vehicle type. The goal is to identify its current vehicle type or time of day produce significantly higher noise. Using Excel, we apply both descriptive, which is mean, median, and standard deviation, and inferential statistic, which is hypothesis statistic, and ANOVA, to analyze the data. This project promotes environmental awareness while developing key analytical skills for future civil engineers. The objective for this project is first to gauge and document the noise level in decibel generated by various car models as they pass by McDonald on Jalan Kampus UTHM. Second, to evaluate the noise level of various vehicle types including car, truck and motorcycle. Third is to ascertain whether the type of vehicle or the time of day has a statistically significant impact on noise level. Fourth is to analyze the traffic noise data using suitable descriptive and inferential statistical technique. And the last is to offer suggestions for controlling or lowering noise pollution in the region based on research findings. The importance of study for this project is first to address growing road pollution issue on campus. It will focus on Jalan Kampus UTHM, a high traffic area near McDonald, surrounded by student and academic facility. It for the highlight impact of vehicle noise on the comfort, focus, and well-being of students, staff, and nearby residents. It helps Universiti and local authorities identify like peak noise time and main noise contributing vehicle type. It also support better traffic management, noise control strategies, and campus planning. Last is to enhance student practical skill in the data collection, analysis, and interpretation for key for civil engineering career. So this is our research area map of the location, which is Jalan Kampus UTHM bersebelahan McDonald.
Assalamualaikum. My name is Noradnin Azmi. My metric number is AF230057. So right now I will explain to you about methodology. So the study was conducted at Jalan Kampus UTHM near McDonald's Parade Raja Johor, a busy area close to UTHM surrounded by both commercial and residential zones. So continuous vehicle movement make it ideal for assessing traffic noise level under varying periods and traffic conditions. So firstly, we select study location and then we determine the time frame, and then we prepare data collection tools, conduct data collection, and then we record noise level, which is used in unit of decibel. So we determine the type of vehicle, and then we do the traffic density, we make time interval. So the next one is organize and tabulate data in Microsoft Excel. So the next one is descriptive analysis to find mean, median, mode, range, and standard deviation. So the next one is inferential analysis, hypothesis testing, and ANOVA. So the next one, we create graph and plot. So the last one is interpret results and discuss findings. Right now, I will explain to you the method we use in this project. It has two methods, which is descriptive statistics and inferential statistics. Descriptive statistics have 5 elements, which is mean, or we call it as average. So the formula of mean is summation xi over n. Xi is each noise level value, meanwhile n is total number of observation. So for standard deviation, the formula is S equals Z over summation of xi minus x squared over n minus 1. So the next one is range. Range is x max minus x min. So for the next one is median. Median is middle value when all noise levels are arranged in order. So for mode, it is the most frequently occurring noise level value. So the next one is inferential statistics. It was used to draw conclusion from the data set. So the first one is hypothesis testing, or we call it as independent sample t-test. It used to compare mean noise levels between peak and off-peak periods. So for non-hypothesis, or we call it as null, it means no difference in mean noise level. For alternative hypothesis, it has difference. So for the formula for hypothesis testing is T equal x1 minus x2 over square root s1 square over n1 plus s2 square over n2. So for one-way ANOVA, or we call it as analysis of variance, is used to test if noise levels vary significantly across different vehicle types. So for F ratio, the formula is between group variance over within group variance. So if p-value less than 0.05, it reject hash note and conclude a significant difference in noise levels by vehicle type.
Hello everyone. So my name is SHARMIMI bin Gardan and I will be explaining about our analysis result. So in this section we will be discussing the descriptive statistic of our study on traffic noise levels along Jalan Kampus UTHM near McDonald's. We have analyzed the mean noise level for different vehicle types. Here are the findings. So for the bus, average noise level recorded was 80.27 decibel, and car, the mean noise level was 71.01 decibel, and motorcycle, the average noise level measured was 74.86 decibel, and truck is the highest noise level was recorded at 84.99 decibel, and the van, the average noise level was 73.46 decibel. Additionally, the overall mean noise levels for all vehicles combined was 77.03 decibel. Based on total of 120 vehicles, this provides an overview of the overall noise the contribution from different types of vehicles. So moving on to percentile values, we have broken down the noise level into key percentile, P25 and P50, median and P75, which help in understanding the distribution of noise levels within each vehicle category. Here are the key percentile. For bus, P25 is 78.18 decibel. For P50, median is 80.2 decibel, and P75 is 81.65 decibel. For car is P25 69.45 decibel, and P50 is 70.2 decibel, and P75 is 71.9 decibel. For motorcycle is P25 is 72.2 decibel, and P50 median is 74.3 decibel, and P75 is 76.7 decibel. For truck, P25 is 83.4 decibel, and P50 median is 85.2 decibel, and P75 is 85.7 decibel. For van is P75 is 70.1 decibel, and P50 median is 72.8 decibel, and P75 is 75.8. These percentiles offer insight into the noise spread, giving a clearer picture of how the noise levels are distributed within each vehicle type.
Okay, Assalamualaikum. My name is Faiz bin Ahmad. My metric number is CF230206. Okay, now I'm going to present about the hypothesis testing that we said hash not equal to 85 decibel, which is the regulation from Department of Environment. Okay, this is a inferential statistic. Okay, by using t-test, we test whether the average noise for each vehicle type is statistically different from 85 decibel. Okay, for the truck, the p-value was 0.977. So we failed to reject the null hypothesis that we indicate their noise is not significantly different from 85 decibel. Okay, otherwise, the all other vehicle type had p-value less than 0.05, means their noise level are significantly different and lower than 85 decibel.
Okay, for the key insight from our analysis, 3 key points that we have stand out. Okay, the first one is truck are the only one vehicle type whose noise level are statistically similar to 85 decibel. So Augustine, they frequently operate near or at the regulation considered potentially hazardous. Okay, the second one is all other vehicle, including bus, motorcycle, and a car and van, which is produce noise level significantly below 85 decibel. Otherwise, the car are the quietest, while the bus come in second highest after truck, but still fall short of the critical 85 decibel. In conclusion, the average noise level across of 120 vehicle was 77.03 decibel. Okay, for the truck, the most consistent contribution to high noise level, nearing to the 85 decibel. Okay, For the car and van, represent the quickest vehicle group and may have minimal impact on our environment noise pollution. Okay, this result can help inform noise control policy, especially in urban planning and traffic regulation strategy. Thank you.
Assalamualaikum. My name is Maisarah Binti Mustapa. My metric number is AF230053. I will explain to you about discussion of this project. The statistical analysis on traffic noise level along Jalan Kampus UTHM presents important insight into how different vehicle types contribute to environmental noise pollutions. Analyzed descriptively, trucks registered the highest average noise level, 84.99 dB, while cars registered the lowest, 71.01 dB. This is consistent with what one would expect since heavier vehicles tend to develop more engine and tire noise. Using the method of ANOVA test, it was confirmed those mean values had statistically significant variation concerning vehicle noise level, p-value equal to 3.89 times 10 negative 31, less than 0.05. The hypothesis was confirmed to be true that vehicle types have a significant effect on intensity of noise. A further test conducted again, such as a post-noise value of 85 dB, proved that buses, cars, motorcycles, and vans mean values well below that of 85 dB, while trucks were not different from that mean. P-value is equal to 0.977. Hence, trucks are is considered to be above that of the 85 dB limit, consistent with longer exposure near places of pedestrian traffic, raising serious noise concerns. Heavy vehicle at night at their frequency of service, especially during peak hours, could be major contributors to elevate noise levels. Motorcycles also produce moderately high noise level on scale or indicating a need for either total vehicle maintenance or restriction on two-wheeler noise. The analysis For conclusion, this study successfully measured and analyzed the traffic noise levels generated along Jalan Kampus UTHM by different classes of vehicles. The results show that the trucks were responsible for averaging the highest noise level, with values being statistically similar to 85 dB. Hence, they are major contributor to a traffic noise pollution in that area. Car, motorcycles, buses, and vans, however, emitted considerably lesser levels of noise, while motorcycles and buses they have fairly high levels because of their mean of engine turning up frequently. Overall, this study provides a worthy input into environmental noise-related issues at the campus, an excellent opportunity to apply various statistically methodologies to develop solutions to real-life engineering problems, especially concerning public health and environmental quality. Universiti Hussein, Malaysia.